In this tutorial, I'll show you how to solve limiting reactant and theoretical yield questions. This is question number 2. The question reads, ammonia can also be synthesized by the reaction 3H subscript 2 plus N subscript 2 yields 2 molecules of NH3. What is the theoretical yield of ammonia in kilograms that can be synthesized from 5.22 kilograms of H2 and 31.5 kilograms of N2? What they're asking for here is the mass of NH3. They give us the mass of hydrogen gas and the mass of nitrogen gas, and we have to figure out which of these two is the limiting reactant. Here's how to figure that out. We'll start by writing out what we know. And we know that the mass of H2 is 5.22. We should convert that into grams because the molar mass is recorded in grams per mole. So to convert 5.22 and 31.5 into grams, what we have to do is multiply this number by the conversion ratio 1,000 grams per 1 kilogram. Notice that the kilogram units for both of these calculations go away when you multiply them. Multiplying 5.22 by 1,000 gives us a mass of hydrogen gas that is 5,220 grams, and a mass for nitrogen gas of 31,500 grams. Next, we need to find the molar mass of hydrogen gas and nitrogen gas, and we can do that by locating the molar masses of each individual atom within the molecule itself. So to find the molar mass of hydrogen gas, and I'll represent this by the capital letter M, we'll take 1.008 and multiply it by 2 because there are 2 hydrogen atoms within this molecule. And for nitrogen, we'll also do the same, but we'll take 14 and multiply that by 2. Multiplying this number by 2 gives us 2.016, and multiplying 14 by 2 gives us 28. Both of these numbers have the units grams per 1 mole. To make the calculations more convenient for us, I'll write these numbers underneath here. The next thing that we have to do is find the number of moles for each of these molecules. And to do that, I'll need to take this number and multiply it by the reciprocal version of this number. Now, if you're confused about that, here's what I mean. Let's say that we want to find the moles of hydrogen, and I'll denote that with the letter N. I'll take 5,220 grams and multiply it by the flipped version of this. So instead of the moles being at the bottom, I'll write down 1 mole at the top and 2.016 grams at the bottom. And by doing it this way, the gram units cancel out. So by calculating this, we should end up with the number of moles, 5,220 times 1 divided by 2.016, and this gives us 2,589 moles. Let's do the same thing for nitrogen gas. I'll denote it with the letter N. We'll take 31,500 grams and multiply it by 1 mole over 28. 31500 divided by 28 gives us 1,125. 1,125 moles. Now, as I mentioned at the very beginning, we need to find out which of these two molecules is the limiting reactant. And to do that, we need to set up 2 ratios. One ratio will compare the number of moles of H2 to NH3, and the other ratio will compare the number of moles of N2 to NH3. Let's start with H2. We have 3 to 2, and the ratio for these two is 1 to 2. With these ratios, I can figure out the number of moles of NH3. And since the second number represents the number of moles of NH3, I'll put an X here, because that's what we're looking for. And I'll put the number 2,589 underneath this 3. And underneath this 1, I'll put down the number 1125. To do this calculation, we cross multiply. So I'll take 2,589, multiply it to the 2. And then multiply this x with the 3 and divide both sides by 3. This gives us 1,726. 1,726. Let's do the same thing here. We'll take 1125, multiply that by 2, And x times 1 is x. Therefore, we get an x value of 2,250. Of these two, the lesser amount is 1,726. Therefore, H subscript 2 represents our limiting reactant, and this is the number that we'll use to represent the moles of NH3. So I'll write down N is equal to 1,726, and that's what represents the number of moles of NH3. Now I need to find the molar mass, because by finding the molar mass and then subsequently multiplying by this number, which has the units moles, we can find out its mass. The molar mass of NH3 is the following. We'll take 14.00 plus 3 times 1.008. Using our calculator, 14.00 plus 3 times 1.008, and we get 17.024 grams per mole. Next, I'll multiply these two numbers. So I'll take this number and multiply it by 1,726. That gives us 29,383. This is in grams. We need it back into kilograms because the question asks for that. To go from grams to kilograms, we divide by 1,000, and that's 29.3. Now look at our two numbers that we started with. Both of them had 3 significant figures. Therefore, our final answer should also have 3 significant figures. This 3 is the last significant figure, but it's followed by an 8. So our answer is 29.4. 29.4 kilograms of NH3 are produced, theoretically, given the following starting ingredients. And there you have it. That is how to solve limiting reactant and theoretical yield questions.